Okay, question 19 here. These are from chapter 6, section 4, I believe, 6.4. So, first thing you need to do, if it hasn't already been done, is to write the denominator in factored form. These already have been, but you can't always assume that they will be. So, always factor the denominator. Reason for that is you have to see whether the factor repeats itself or whether you have unique factors. That determines how many pieces of the partial fraction you have here. For example, in part A, you have to have a over x plus b over x plus 1, but because it repeats twice, you have to have a c over x plus 1 squared term. Whereas here, you need simply an a over x and then a b over x plus 1. So you can see that the partial fractions are set up differently. Now, what you need to do next here in part A, we'll fully finish part A, and then we'll go into part B, is you need to multiply both sides by the LCD, which is x and then x plus 1 squared, and then over here, same thing, x plus 1 squared. What happens on the left is the denominator cancels with the LCD, and you're just left with the numerator, 3x plus 2. Now, as you take this LCD and multiply it by each piece, when it multiplies over here to the a piece, the x would cancel. You're left with a times x plus 1 squared. When the LCD multiplies over here to the b term, one of these x plus 1s cancels only with one of these x plus 1s. So b multiplies x times x plus 1, and then the x plus 1 squared here cancels with the x plus 1 squared here. So c multiplies x. What you need to do next is choose what we've called convenient values of x that would eliminate a piece of this right side. For example, if I let x equal 0, and the reason we can do this is it doesn't matter what x equals, we're solving for a, b, and c, so x could be anything. And if x particularly is 0, then that cancels the c term, also cancels the b term, and will allow us to solve for a. So if x is 0, 3 times 0 plus 2 is 2, and then here 0 plus 1 is 1, 1 squared is 1, 1 times a is a, and then these, the b and the c term would have canceled that, so just from that one value of x we found the value of a. We can do the same thing if we let x equal negative 1, because that's going to cancel this b term here and this a term here, which will allow us to solve for c. So if x is negative 1, we get negative 3 plus 2, which is negative 1. A cancels, the b term cancels. Negative 1 times c is negative c. So c equals 1. Now, what we have to do next is just choose a random value of x. We've exhausted the two choices of convenient values. But we can still solve for b even by choosing a random number for x. For example, if we let x equal positive 1, but we also need to use the two values that we just found. If we let x equal 1, a equal 2, and if we let c equal 1, we're going to be able to find the missing value b. So if x is 1, we get a 5 out of the left side of the equation, and if a is 2, and if x is 1, we get 1 plus 1, which is 2, 2 squared is 4, 4 times a, which is 2, 4 times 2 is 8, and that's a plus. Now we don't know b, but we know that we're letting x equal 1, so 1 plus 1 is 2, 2 times this 1 is still 2, 2 times b is 2b, and then we know that c is 1, and if x is 1, 1 times 1 is 1. Now 8 plus 1 is 9. If you subtract 9 from 5, you get negative 4 is equal to 2b, and then you get that b is equal to negative 2. So we can write the partial fractions now. It's 2 over x plus negative 2 over x plus 1 plus 1 over x plus 1 squared. Part B, we do a similar thing. We multiply both sides by the LCD. Here the LCD cancels the denominator, so we have 3x plus 2. And over here, as the LCD multiplies each piece, as it multiplies the A piece, then the denominator x cancels with this piece of the LCD, so A multiplies x plus 1. And then as the LCD multiplies the B term, the x plus 1 denominator cancels with this x plus 1 factor. So B multiplies x. And we just do the same thing we did in part A. We can actually use the same two convenient values. If we let x equal 0, then we have 2 is equal to A. If we let x equal negative 1, then we have negative 2. That term would be gone. Negative 1 times b is negative b. Actually, let me backtrack here. If x equals negative 1 here, then this is a negative 1 there. So b equals positive 1. So these partial fractions would be 2 over x plus 1 over x plus 1.